to talk to you a little bit about how we collect evidence of global climate change from the Earth's ice cover. And on the first slide, you'll see some images of the different places where Lonnie and I have traveled to collect ice cores.
You can see that we're very fortunate to live on a planet where we have many recorders of our path, the climate. And today we're going to talk about one of these recorders, which is the ice cores. All right, so we're going to be looking at ice core records, and we're very fortunate to have ice core records from around the Earth, from Antarctica and Greenland, but also from the very highest mountains, like in the Andes of South America, and from the Himalayas. And in these are a marvelous history of our past.
All right, so I'm going to tell you a little bit about what's on this slide. So in the upper left is a map of Antarctica, which is the Earth's largest ice sheet. In the middle is a photograph of an ice core, and over on the right is a photograph of a thin section of the ice core. And if you look really carefully, you should be able to see bubbles in the ice. And scientists, using special equipment in their labs, can essentially take the air out of those bubbles and then measure the concentrations of different gases like carbon dioxide and methane, which are two of the major greenhouse gases that are currently warming our planet. If you look at the graph on the bottom, you'll see a red line and a blue line. And on your right is today. The axis on the bottom is time. So if you look at the graph on the right and then look to the left, you'll notice that those curves go up and down about 8 times. And this is an 800,000-year record, meaning it's almost 1 million years long, and it's showing you 8 ice ages, 8 times when the Earth was warm like today, and then when the Earth was cold. And what you'll notice is that the red line, which is methane, and the blue line, which is carbon dioxide, go up and down they go up and down together. So when it's warm, we have more of these greenhouse gases, and when it's cold, we have less. If you see on the right side, you'll see the 2 dots or the stars, the red one and the blue one. That shows you what the concentration of carbon dioxide in blue and methane today, or methane concentrations are today. So what you can see is that those concentrations of those 2 important greenhouse gases are higher than they've been in the last almost 1 million years. And then if you just follow the arrow up, you can see how high those concentrations are predicted to be at the end of the current century. So that's 91 years from now. Now, in this slide, we're going to show you how we reconstruct the Earth's temperature history using using oxygen isotopic ratios that are actually measured from the snow or the ice. So in the upper right, you'll see a graph or a map of the world and the 2 red circles. The red circle to the right is over the Tibetan Plateau, where Lonnie and his team have drilled ice cores for the last 25 years. If we take the average of the oxygen isotopic ratios from those 4 ice cores, and then in the other circle we have 3 ice cores from the Andes of South America, and we put those together, we get this green graph at the bottom. And essentially, again, today is on your right, and this is a 2,000-year history. Now, up above on the blue you see the reconstructed temperature history of the northern hemisphere in the blue, and then in the red are the measurements we have. Those are actually using instruments, so that's the instrumental record. You can see how short it is. But the important thing to notice is how similar the isotopic history from ice cores is compared to the curve in blue, which is reconstructed from tree rings and corals and lake sediments, as well as ice cores.
But if you look at the map, we, over the last 33 years, have conducted over 57 expeditions to 16 different countries around the world to collect these archives.